So write expansion of this x square I cap plus y square j cap dot. What is dr bar? Dx I cap dy j cap dz k cap. So the limits are 0, 0, 1, 1. Now the further expansion of this, I dot I will be 1. So this will be integral of x square dx 0 to 1. I dot j will be 0. I dot k will be 0. J dot j will be y square dy. So this should be x cube by 3, y cube by 3, z cube by 3. Now what are the limits? Limits are 0, 1, 0, 1, 0, 1. So this should be 1 by 3. Lower limit is 0, no? 1 by 3. So this everything will be 1 joule. Okay, fine. So if a variable force acts, that too the force is acting in a plane, no? So this is a method. Just as a mathematical. So today we'll just explore like different types of forces. Different types of forces, you can see that. Anything it can be. So you should be in a position to determine the work done. See, like this is all mathematics here. You may come across a situation. So usually what are the forces, like what we earlier did, problems, application of wedge constraint, that is the problem. It's only mathematical base. A student must have a basic idea for different types of forces, how to get the work done. This is the main purpose here. I'm making clear it's a just pure mathematical idea. Okay, now question number 4. Take that one. Here you see that earlier it was a three-dimensional force, no? Now the force is acting in a plane, in XY plane. Earlier it was acting in a space. So then there should be work done equal to a bar dot dr bar. So the limit will be 1, 1, 2, minus 1. So this will be 3x square y I cap dot dx I cap dy j cap. Then this will be here what you are going to write it here. 3x square y is there. So let's multiply this one. I dot I. So 3x square y dx plus x cube dy. So and the limit is further 1, 1, 2, minus 1. Now let's a bit difficulty you can see here. Look at the way you integrate terms. 3x square y dx x cube dy. How to overcome this particular situation? So there are two alternatives are there. Let me put both. So you look at this one, x cube dy, you expand it. What do you get? Expansion of x cube dy. X cube y. If I expand x cube y, so I'll just come out of the problem. So if there is a derivative of x cube y, what you can write it as? 3x square dx y plus x cube dy. Is it okay now? So what is this quantity now? So what you can write it as? So this bracket term, what you can replace? Derivative of x cube y, the total bracket term, I can replace as derivative of x cube y. So this should be work done equal to integral 1, 1, 2 comma minus 1 derivative of x cube y. So what happens, sir? Dx all, everything I replaced with this particular quantity. The bracket is what I should replace with a derivative of x cube y. The integral and derivative will cancel out. Will end up with only x cube y. The limit are 1 comma 1, 2 comma minus 1. So how to substitute this limit? Substitute the upper limits. The substitution of upper limit will be, in place of x, substitute 2 cube. Then minus, first upper limit I substituted, then the lower limit. Now I'll give color for the limits, so it'll be easy for you. I'm going to substitute the, so first upper limit, no, the red color, this will be 2 cube minus 1. Then substitute the lower limit. Lower limit is what? Value of x is 1, no? 1 cube. Value of y is minus 1. There's a method of searching for this. Call okay, the derivative and integral will cancel out. So I'll give this one. Derivative and integral both will cancel out. So finally, so how much we are getting? Minus 8, minus 8, minus 1, minus 9 joule. So this should be the our. So what is work done? Minus 9 joule is what? The answer. You may find little bit difficult, sir, how you can cancel the integration and derivative. As there's a partial derivative, it's a partial derivative method. Later on, I think in maths you are going to learn.
So it's 1 cube into 1.
1. No? Yeah. This is little bit, sir. We didn't understood, sir, what you made that integral and derivative. How you can cancel out? It's a integral and derivative. What happen? They are opposite of each other. Derivative what happen? Derivative means we are splitting up. We are expressing the variation. Integration means what happen? We are adding up that variation. So now, any alternative method, can you tell us a little bit, because we are not that good in mathematics to search. What is the meaning of this? What is the meaning of this integral of derivative of x cube? I will just explain the question number 4 by another method. So what actually meaning of this one? I'll add one page. Now we'll try to explore the meaning of this one. So I'll bring back the question. I'll bring you the question. Or alternative method. Work done is equal to, what was the form? What was the question? Question was 3x square y the limit was 1 comma 1, 2 comma minus 1. So here, what is the meaning of this? So you just keep it like this here. Integral of 3x square y dx plus x cube dy, and 1 comma 1, 2 comma minus 1. Let me rearrange this one. So it is actually 3y integral of x square dx. Definitely you can see that the way we write things, little bit confusion for everyone. That's why the mathematical approach was brought here. First, where you are at 1 comma 1. No? When you are at 1 comma 1, what is the value of y? The value of y is 1 and x is, you are moving along the x-axis where the displacement is from x equal to 1 to x equal to 2 meters. So what should be the limit? Limit will be from 1 to 2 meter. And what is the value of y? The value of y is 1. You able to get this? Initially where you are? You are at 1 comma 1. Are able to, you are at 1 comma 1. Then I'll integrate. First I'll integrate along x-axis. You see dx. So what should be the value of y? First I'll move along x-axis. So what is the value of y? Y will remain 1. So where all y is there, I should write 1. Then I'll integrate along x-axis. So 1 comma 2. So finally now where I arrived at 2 comma 1. After integration of this, I arrived at 2 comma 1. Then I'll integrate along y-axis. Then what is the value of x? The value of x is not 1, should be 2. So I should write here, this is 2. And this limit should be 1 comma minus 1. So next I'll substitute all the conditions. What are there? So what is the value of y? Y is 1. This is 1 comma 2 x square dx. Then after integrating, what will happen? This x has become 2, no? 1 comma 2. So this is 2. Then 1 comma minus 1 dy. This is actually the meaning of that. Okay, this will be 3. This will become x cubed by 3. 2. Integral, this will be y. 1 minus 1. 3 get cancelled, so this will become 9. I'll substitute the limit. So this will be 3 square minus 3 cube, 2 cube minus 1 cube, 2 into minus 1 minus of, let me substitute limit here. No, simplification of this will be 8 minus 1. This is how much? 2 minus of minus 4.
Sir, that
Wait
is
a
2
second.
cubes, sir. X
2
cube
cube, no?
into
Let me check it. 3x square is there, no? Here x cube, no? Yeah. Okay, thank you. Some data missing. This will be how much? Will be 8, no? So this will be 8 into minus 2. Check it, how much will come?
minus 9.
Minus 9 joule. Okay, are you able to understand? So this is a little bit, you should be very alert here. So the value of y, because first I'm integrating along x, then 1 comma 2. What is the value of y? That should be substituted. Then I'll integrate along the y-axis. Then after integrating along x, you are at now what happen? First you'll integrate from 1 comma 2 along x. And what is the value of y? That should be substituted. Then you are where you are at 2 comma 1. So what is actually the path? The path is from 1 comma 1. What is the path? The path is, so here I think I'll give the explanation at least mathematically. So 1 comma 1, we are here. Then what we do? 1 comma 2 will go it. So like a 2 comma 1 will come. So 2 comma 1 will be here. Then afterwards happen, we'll go for 2 comma -1. So -1 will come here. Getting this one? So what is the path? The path is like this. You need not to, so that is actually the meaning. First you are integrating along x-axis, then integrating along y-axis. Okay, all of you. So I think which one you feel convenient. I think this derivative one much easier, no? Mathematically. The derivative one is much easier. Just bring the derivative, cancel integration derivative, substitute upper and lower limit. Or else you should go for the taking care of the limits.